For storing numbers here, this will store it as a floating point number, which is the default in MongoDB shell, which is based on JavaScript. We can also store that as an integer by using this number int and putting inside this bracket and quotation mark. So now this gets stored as an integer. Also, while storing this in the backend, this will actually be stored as a floating point number with many decimal places, and in the end there will be a imprecision like 29.00002. It can be like that. So that tells us how these numbers get stored. And now here we are storing this very large number. This is a 5 billion, for example, company valuation. We store that as an integer here. When we see it, the valuation is completely different than what we stored, because such a large number cannot be stored as a 32-bit integer. So this gives completely wrong result. And this number is the maximum number that can be stored as 32-bit integer. So when we write this, we get the result which is the same as we stored. We store a number which is even one more than that. So this gets out of the range. This goes into a negative range here. This is the maximum number that can be stored as a 32-bit integer. So for that, we remove the number int. So this gets stored as a floating point number, and here we see that this is the same exact number that we stored. Even if we want to store large number as an integer, we have something called number long. This is a 64-bit integer value. So we can use this. We have to pass that as a string. This still gets stored, but the string is recommended for especially for large numbers. This will pass the limitations rather than if we just store numbers, store it as a number. So we see that this number gets stored as an integer number long. Similarly, a number which is this long should be stored with these strings to make it better rather than just the number. And we delete those two and we insert a new person, this name and some amount, and we store that as an integer as 10, and then we put an update one function on that. So update every increment by 10. So then we get this 20, 10 plus 10, 20. And now this will be stored as a floating point number. Even though we had integer number when we first stored it, it will be converted into a floating point after we put this update function with amount. So to store that also as an integer, we can use the same method number in update function also. So the result is still 20, but this stored as an integer. And similarly with number long also, we can use this. So with increment, we just use this. This will be stored as a floating point number rather than integer. So for that, similarly, we have to put the method in. And then, for example, we have this new collection here. Insert A and B as a single document, and then in an aggregate function we put this projection. So this project stage, and then we give this name of field as result, and then we subtract operator to subtract B from A. Use this dollar sign. So the result that we get slightly different, should be 0.2, and since it is a floating point number 20000, but this has a slight imprecision in both of these numbers, so the result also is slightly imperfect here. So this tells, and this is stored as a floating point number. This explains that. Now we talk about the performance of a MongoDB server. What influence the performance? There are several factors that can influence the performance: how efficient the queries and operations are, the indexes. We need to see the right indexes for right collections. We need to see with the need of application and what kind of indexes are needed. And then if the data schema is fitting to the collection that we have. So we have to see all that. And then to increase the performance, there is a replica set that MongoDB automatically creates. So when from shell or driver we pass an operation, for example a read operation, so the MongoDB server has a primary node that performs this function from the data set. So anything read or write, but it automatically creates a replica set, a replication of the same operation, the data, and store it in a secondary node. So if for some reason the primary node is down, so we can read or write data into secondary node. So this will not create any problem. Also, when there are a lot of read write operations, so then also secondary nodes can be helpful. When primary node is busy, we have, for example, thousands of operations per second. So we can use secondary nodes in that situation. Also, when primary node is active, we can still use secondary nodes. So this improves the overall performance of the MongoDB server. Now we have something called a capped collection. In the capped collection, we have a fixed amount of documents that we can have at a certain time. Also, if the limit exceeds the previous document, the document that we stored first will get automatically deleted. So for applications where we need such an operation to be performed, where we need a small range of document, and we want to every time delete the previous ones, we can use this will be very efficient. So we create the collection with this function, and then this defines it as a capped collection, capped true. This is by default also true. We give the size, maximum size, and the maximum number of documents. that the capped collection can have. So pass three documents, insert one name. So these are the three documents, Max, One, and Anna. So, and also this gets automatically sorted in the order that we inserted them. So Max first, then the other two. We can also put them in the opposite sorting by using this -1, and we put this natural operator, so the natural order that we inserted them, so that will be opposite here. The newly inserted will be at the top. So then if we try to insert a new document here, that will be get added, but the first document that we add into this collection will automatically get deleted because the maximum size of the documents that can have here is 3. Then we have a concept called sharding. So like replica, for replica set we have multiple nodes. You can have multiple secondary nodes, but they will all be on the same system, same server. So the secondary nodes can do the work when primary node is not free, is inactive. But in the case of sharding, we have multiple servers running together, and they all split up the task, the read-write operation that we have, and they're working together. So if we want to fetch some data, we will have to put the operation on every shard. These are multiple, these are called shards that store some chunks of data. So for a find operation, we have a Mongo's router that will look for the key on each shard where the data is stored. If it knows the key exactly where the data is stored, it can directly fetch that, or otherwise it will have to broadcast an operation for the key to every shard. So this is also how the data is performed in multiple different chunks. It is stored like that.